On today's Maker Mashup, part 2 of our DIY laser series. So in today's Maker Mashup, we're going to be working on part 2 of our DIY laser series, and that is going to be covering all the electronics and the basic setup of the Laser Engraver. Now, the L301 is an open source laser engraver, and in our last episode, we went ahead and built the frame for this. And if you missed it, there's a card up at the top that will walk you through the assembly of this. And as I said, all open source. So this is a great way that you can modify this build yourself. So let's talk for just a second about the completed build. As you can see here, this is a 400 by 400 millimeter frame. I have it actually sized down on the interior for a roughly 300 by 300 millimeter frame. Now, because I went with air assist on this, I lose about 20 millimeters. So I could increase this frame a little bit if I needed a true 300 by 300. But with the air assist on here, I end up with about 280 by 300. And this works really well. And we'll cover that in today's video. Now, if you've been following the channel for a while, you know that this is very much an X301 style frame. We did make some improvements, and those improvements will be coming to the X series printers. Most notably, most of the patrons have already seen a lot of the cable chain setup here, and that's one of the things that we added to the L301 right from the start. So all the wiring is done through the cable chain, and it really does offer a lot cleaner of a look, but it also makes it a lot easier for the printer to work because you don't have a cable, or in this case the laser cutter, a cable flopping around during the operation of the unit. Now, one of the other features of my unit in particular is that I have a separate module for the laser cutter, and that's right up here in the front. Now, that gives me a couple of different options outside of the core functionality of the printer, and that's that I can manually control the laser. I can control it a number of different ways. First, in this unit, I went ahead and powered it separately. That's the way this module is designed. And I like that because I can run all the motion control on the laser cutter itself without ever having the laser even armed or powered. So that really prevents mistakes from happening. And for me, laser safety is pretty paramount. And we'll talk about that in a little bit coming up. Now, getting back to this module, it also allows me to power the laser with just a very, very slight amount of power to focus the lens without having to control it and have it burning through whatever object. A lot of the laser cutters that you see that work with only PWM, when you start to turn them on, even at the lowest level, they're starting to cut. This has a really high level of granularity. I can actually get down very low with the laser to the point where it's extremely dim, but it allows me to focus that laser diode before I'm using the unit. So again, for me, it was more of a safety choice. And then the other thing the module gets me as well is using the temperature sensor that's in that laser diode to see how hot the laser is getting. Now, it usually runs anywhere from 20 to 25 C when it's operating, but as I would maybe engrave something a lot larger, that temperature might go up, and it's a good way to check to see if your laser diode is overheating. One of the other things that I want to do with this unit in the future is convert this also to a plotter or create a separate one as a plotter and a vinyl cutter. Now, by changing the head of this unit, I'd be able to reuse absolutely everything here except for the part where the laser is, and then that would have a mechanism so that way the pen and or the blade for a cutter would be able to just go down, meet the material, and then either cut or draw with this. So those are going to be upcoming videos that we're going to have on this, separate from the laser series, but really showing the versatility of this design. So let's talk about the safety of this laser engraver. Now, I'm just using a standard brick type power supply for both Marlin and for the laser engraver itself. So the laser head is 12 volts, but you can purchase these little switches, and these are really great. They just fit in line with the power supply, so you can turn your Laser Engraver or your Marlin board off with these. So buying 2 of these gives you the advantage that I can power up Marlin and use all the kinematics to move around, make sure things are going to look right, and never have the laser on. Not even in a state where if I made a mistake, the laser would kick on. So when this is off and I have the module off there, I can do everything with this and not have to worry about wearing safety eyewear. And I feel rather protected just simply knowing that there's no power going to that laser module when I'm setting all of this up. Now, a lot of the cheaper Chinese ones don't have these types of safety features built in, and when you're powering up the unit, you're powering everything on. So this is a real advantage to some of the other designs that you might see out there. So now that we've talked about isolating the power on our laser diode itself, we're now going to talk a little bit about laser eyewear. Now for this unit, you can see it's not enclosed, so anybody that is in the room with you needs to be wearing some sort of protective eyewear when the laser is operating. So getting to the eyewear itself. Now, this is a pair of safety glasses that came with the laser diode. And I've seen a number of YouTubers that say, make sure you wear these glasses because it's going to protect your eyes from the laser. But I say I don't believe that even in the least. Now, I'm sure there are plenty of Chinese manufacturers that produce quality eyewear. However, this set of eyewear that came with this doesn't have any safety rating on it. It's a pair of green plastic, and I honestly have no way to reasonably test the quality of these glasses and what they will actually protect you from when using a laser like this. So let's talk about what we should be wearing. Now, this is a pair of glasses manufactured in the USA, and honestly, it doesn't matter where they're manufactured as long as they've been certified and they say on them, just like these do, there's an engraving that says exactly what these are protecting you from on the lens. Now, yes, we could talk about a place that perhaps is just lasering that on there and then telling you you're getting protected and you're not. But the difference is that I bought this from a reputable company. And there are a number of different reputable companies that people have bought laser eyewear from and protected you. And there are so many different ones in the United States and other countries. I suggest you look around and get a pair of these. Now, this laser unit on here cost $179, and that included the laser glasses that are with this. I can pretty much bet that the quality of these glasses is not going to be the same as this pair that I paid $89 for. So half the price of these glasses is the price of that laser itself. So the quality that you're getting in this is a much better product than you're going to be getting from a manufacturer who's just including these more or less for free along with the laser diode and the other product that you purchased. So don't be afraid to spend a little bit of extra money. If you're setting all of this up and you're putting this together, really having good quality eyewear is very, very important. So don't build this unit, don't assemble this unit if you're not going to take the time and expense to go ahead and get good quality safety wear. Now, I know this probably seemed like a bit of a rant over safety, but I encourage you to also look in the description. I've linked to Styro Pyro. He's got over 1.6 million YouTube subscribers, and he talks in detail about cheap, inexpensive laser eyewear like this found on Amazon and eBay in comparison to reputable manufacturers in the US. And he runs some tests with lasers and shows you the difference and the minimal protection that you get from something like this. So please spend the extra money, buy good protective eyewear before you finish the rest of this build. So now that we've talked about the features of this build and we've talked about laser safety, we're going to now proceed with doing the electronic portion of this and getting Marlin set up so that way we can start using our laser engraver. So with all that said, let's get to work. Once we get all the 3D printed parts completed, we'll start by assembling the main board. The SKR version 1.4 is placed on top of the base plate and attached with some M3 6mm screws. Now we switch to the cover assembly and place our display into the cover. This is secured with M3 6mm screws. Next, we attach the 12-volt 60mm cooling fan with some M4 20mm screws. Next, we'll attach the ribbon cables to the display itself. Then we attach a female panel mount jack to the side where we will insert our power plug. This completes the cover assembly. Now that we have the cover assembled, we're going to insert our fan from the display into an always-on fan port. Then we'll attach our power jack to the power input on the main board. We'll complete this section of the build by attaching the ribbon cable then to the main board. Make sure that you're hooking the EXP1 and EXP2 to the proper ports. It's very easy to mix these up. Now we switch to the laser module installation, and we're just going to attach this to the carriage itself with some M3 screws. Once all the M3 screws are attached, go back and tighten everything down. You'll want to make sure that you don't over tighten this, as that will possibly damage the laser module. Now we'll attach the cable chain tower to the left hand side of the build, and we're going to attach this to the frame with some M5 8mm screws and T-nuts. Now we're going to attach the carriage cable chain mount and air assist module. We're attaching this with M3 8mm screws. There are two versions of this part. One has the air assist, the other does not. Air assist will improve the efficiency of your laser. However, it does come at a cost of 20mm of cutting area in your build. Now that we have the mount attached, we're going to insert our 5015 fan, and we'll also use some M4 20mm screws and nuts to attach the fan to the mount. Once the fan is mounted, you'll use the hole in the center of the mount to feed through the wires for the fan. Now we move on to the cable chain installation, and this is a 10 by 10mm cable chain. You'll need to work the wires for the laser module through the cable chain, and then from there we'll be ready to install it on the build. Now we're going to attach the cable chain to its mount, and we're going to do that with some M4 8mm screws and nuts. Countersink screws work extremely well to help hold the chain to the mount. Now we'll use the same M4 8mm screws and nuts to attach the cable chain to the carriage itself. Once the cable chain is attached, then you'll want to insert the plug into the laser module. The next part is the worst part of the build, where you're going to need to feed the fan wire back through the cable chain all the way through to the front of the unit. Now this is a bit of a pain. The only other solution here would be to run the wire at the same time as the other one, and then you would have to solder in the back. So you can pick your poison on how you want to feed this wire through for the fan assist. Next, you'll need to feed all the wiring through the side holes on either side of the cover. Now, I apologize, the video for this was a little bit hard to shoot, but what you'll need to do is insert each one of the wires through the side, and then you'll need to plug it in. The air assist plugs into fan 0 on the main board. You'll need to make a short patch cable that is going to go from the extruder port to the PWM input on the laser module. Make sure you're matching up the proper polarity of the positive and negative with the extruder to the wires that are going to the PWM module. Next, we're going to wire in our steppers. Just feed these through the cover as well and plug both the left and right stepper in. Let's just review the connections we've made. We've got our steppers here, the extruder, and fan 0 is what we've plugged our air assist into. Once that's complete, we'll put the cover onto everything. Make sure you're feeding all the wires in and out as necessary to make sure that nothing is pushing up against the internal fan in there and it spins freely when the unit is powered on. Be careful not to damage the SD card while putting the cover on, and then you'll use an M3 8mm screws. There's 2 on the front and 1 on the back that will secure the cover to the main base plate. Now we'll attach our inline switch to the unit itself. Just insert that into the jack port here, and then the other half will attach to our power brick. Position the enclosure to the far left, and then we're going to secure this with some M5 8mm screws. The final part of the construction is attaching the module. There's a 3D printed part and you'll attach that with 2 screws to the module into the frame. And then from there, you'll go ahead and install the cover. Feed the wires through the cover and then we'll attach that with some screws on the top. And then lastly, we'll install the buttons and those buttons will press down on the unit itself. This protects the entire module from anything being dropped on it or damaged. Once that's completed, we'll plug in our inline power switch, and this will then hook to the other 12-volt power supply, which is powering this module. The last step was to add some wire wrap to the rest of the wiring here and give it a nice clean look. Moving on to the firmware installation, there really isn't much to address with this. All you'll do is use the firmware that I have in the repo, and you'll need to set the appropriate motherboard. In this case, I'm using a 1.4, but you can use a 1.3 as well. All the rest of the firmware has been configured for a laser cutter, and it's also been configured for the power assist fan. If you don't have a power assist fan, you can disable the M106 feature in the firmware. All that's left is to compile the firmware to the main board. Okay, so we've got everything assembled. We're ready to start doing some laser cuts with this. Now, before we start lasering this, I do want to talk about the type of things that you can laser with this. So natural products are pretty easy to laser, and for the most part, they won't represent anything that could be toxic to you. Now, when you use a laser, what that laser is doing is burning away and basically incinerating anything that that laser is hitting. Now, for things like wood, you're going to get what you would expect, which would be the type of smoke that you find from a campfire, and your shop's going to smell like one too. My wife can always tell when I'm starting this baby up because it smells just like we've got a campfire inside the house. So be safe about where you're using this and what you're going to be lasering with it. Now, other things like PVC, you might think that any old plastic can be put in here and you can engrave on it. That is not true. If you put something like PVC in here, it will create chlorine gas from the off gases from the laser hitting it. Probably not something that you want. So we should exercise a lot of safety around the materials that we're going to be putting in there. Obviously, because this is a laser diode, you won't be able to laser things like glass. That's really going to require a CO2 laser. Acrylic, clear acrylic won't work as well. So anything that's semi-transparent or even reflective, another thing you probably don't want to put into the laser cutter because that will just bounce the laser beam around the shop. But for a lot of other things, it will work really well. Just be knowledgeable in what you're going to be putting into your laser and make sure that whatever it is something that is not going to be off-gassing a chemical that is toxic to you. And there are a lot of good resources on the internet that will tell you what sort of things you can put into a laser cutter and things that you shouldn't. So what I'm going to be doing for our first cuts here is I'm going to put just a piece of cardstock in here, and we're going to go ahead and cut that, and then that will wrap up our video today. But it will show some of the things that I found in Lightburn that we'll have to use to make sure that we are engraving properly and don't have problems communicating with the unit with Lightburn. Now, you don't have to use Lightburn. I think it's relatively inexpensive software and works really, really well. I have no relationship with them other than I purchased their software. There are other ways to do this. I'm not going to cover it in this video today. Okay, so here we are inside a Lightburn, and the very first thing it's going to do is prompt you to create a device. And I suggest just going in here and creating manually, and then going down to Marlin. And then once you select Marlin, you'll select also that you are using USB serial, and you'll give your device a name. I'm just going to leave that as Marlin, and then what we're going to do is set the build area of the device. Now, because I'm using the air assist, my y-axis is only 280, but you may put 300 in there if you're not using air assist. And the origin of our laser is in the front left, so we'll just click next on there, and now we're all done setting up the connection between the Lightburn and Marlin. Now I do want to cover one more thing. Along with selecting the COM port down here for your device, what you'll also have to do is go back into your device settings. And then over here, instead of transfer mode being buffered, set that to synchronous. I ran into problems using the Marlin software with the buffered connection, but that was all resolved by using synchronous. So just a tip there for anyone setting this up. Once you've got this complete, the rest is to put your material on here, and then from there we can start running our laser burn. Let's talk about focusing the laser. Now, it's key that when you are going to be putting a material in here to laser, that the material and the laser is focused on the material properly. Now, I've seen other YouTubers where they say just have it make a fine point on the top, and that's enough to go ahead and laser and engrave whatever material it is that you're using. Now, I disagree with that a little bit because I've used CO2 lasers in the past, and it's really critical. It makes a huge difference in where the laser focuses to how effective that laser is. Now, as an example, if I'm trying to cut a piece of material and the laser light is focused only on the top of the material, then that's where the most power of the laser is. Now, that becomes a problem because if I've got a thicker material, all the power is on the top and none of the power is going through the rest of the material. So how a lot of people solve that problem is they make a lot of multiple passes on something, and that ends up usually in what's called scorching around the particular area that you are trying to cut or engrave. Now, for these laser diode setups, it's pretty easy. Most have a small lens that you can focus by turning on the front of the laser or on the bottom of the laser where the light is coming out. It's very easy to adjust. So when you're trying to focus your laser, you may run into a problem where the material that you have is diffusing the light. And this cardstock is an excellent example of it. When I started lasering this cardstock, what I found is that it was very hard to focus on this because as the laser hit this, it diffused the light around it. So with safety glasses on, it was really, really hard to see the difference between where the focal point was and the light that was being diffused. Now, that problem is actually very easy to solve. Now, the way that I did it was to go ahead and use a thermal label. Now, the thermal label does not diffuse the light like cardstock does. This is a little bit more porous because people may want to paint or watercolor on it, and it absorbs water very well. Thermal labels don't do that. They are rather opaque, and they also do not diffuse the light very well. So it's really easy to see where the focal point is on something like this. The video really doesn't do this enough justice, but it is much easier to see through the safety glasses the sharp point that this is making by using this thermal label. And then to offset and point at the center of my cardstock, I'm using a few sheets of paper which allow me to get the center of the actual cardstock, measuring the thickness of the cardstock and measuring the thickness of the sheets of paper along with this label. Now that we've got everything all tuned in, let's run a test run. All right, so I think our first attempt really did come out great. We were able to take the cardstock and we cut it out, and we were also able to engrave on it. All of that was done with just some random settings that I had attempted to tune in there. I think it came out really good for the first attempt. That's going to bring the end of today's video. If you enjoyed it, make sure you mash that like button, and don't forget to share and subscribe so you don't miss any of our upcoming videos. If you'd like to help support projects like this, consider checking out our Patreon page. Our patrons receive early access to content before it's released on the channel. And if you need help building this project or any other project, please consider checking out our Discord, where all of our members help each other in a large open makerspace community, and you can get help with this project or any other project that you are working on. So with all that said, I want to say thanks again for watching, and we'll see you all next time.